For this video, we're finding the area of an equilateral triangle, and right now you can pretend that this is an equilateral triangle, meaning that all the sides are the same. So I'm going to call that side S. Well, there are lots of different ways to actually approach this problem, but I know that the area of a triangle is 1/2 the base times the height. Well, I know that my base is S because all the sides are the same, but I don't know what the height is. The height is the altitude that I drop down right here. So one way to find it is actually just to use the Pythagorean Theorem. And if this is S and we have equilateral, that this bisects this opposite side, so this would be 1/2 of S. And this, of course, is my height. So if I wanted to use the Pythagorean Theorem, I could say that 1/2 of S squared plus my height squared equals S squared. 1/2 of S times itself is 1/4. S squared plus H squared equals S squared. And I'm trying to solve for height, so I'm going to move the 1/4 S squared to the other side, so I will subtract it. And I have height squared equals, this is 1 S squared minus 1/4 S squared equals 3/4 S squared. And then I would take the square root. So height equals plus or minus the square root of 3S squared over 4. Well, we're talking about a height here, so we're going to take the positive square root. The negative isn't worth mentioning, really. And then that's our height. So our formula becomes 1/2. Our base is the length of the entire side, which is an S, times the square root of 3S squared over 4. And the square root is on the entire expression here. So when I break this down, I have 1/2 times S times the square root of 3 is going to stay. The square root of S squared is just an S, and the square root of 4 is 2. So recombining, I have 1/2 times the square root of 3 over 2, which is the square root of 3 over 4 S squared. And that is my area formula for an equilateral triangle. Another way to do this is actually to use sine. So if this is equilateral, it's also equiangular. So this is 60 degrees. And I know that sine of 60 degrees, and you could also, of course, use this pi over 3 if you're using radians, equals the opposite leg over the hypotenuse. So H over S. Well, I know that sine of 60 or sine of pi over 3 is equal to the square root of 3 over 2. That's from my unit circle, equals H over S. If I multiply both sides by H, I have that the height equals the square root of 3 over 2S. So when I do the area formula for my triangle, I have 1/2 base, which again is S, times the height, square root of 3 over 2S, and I'm back to the same formula. 1 times square root of 3 is square root of 3, 2 times 2 is 4, S squared. Another way to do it is actually using 30, 60, 90 triangles. This is 60 degrees, this is 30 degrees. And if you look at it, the ratio is 1, 2, square root of 3. And this was my 1. That's 1/2 S. This is twice that. This is the square root of 3 times that. So my height is the square root of 3 times 1/2 S, which we also have right here. So any way you do it, the formula comes out for an equilateral triangle, area equals square root of 3 over 4 S squared.